All right, so we're gonna talk about proving identity. So we also gonna talk about some harder cases today. So today, some people says 11 is a question 11. Is that what you have problem with? Okay, 11 says cosecant of theta minus sine of theta is equal to cotangent of theta cosine theta. Um, so I am gonna start over again, see what happened. All right, so we have a questions here. Which side is more complex? They're about equal. Huh? The right side is more complex. Okay, so you can go either way. So let's try either way. Okay, so let's only do one side at a time. Do not subtract it to the other side. So what you're gonna go is you say, okay, well, I can change this to 1 over sine of theta minus sine of theta. Is that okay? Now, can I combine those two fractions? What do I need to do to combine those two fractions? You must, like, just think about if you have 1/2 minus 3, you must multiply this 2 over 2. Does that make sense? To have a common denominator? So what do you need to multiply this side? Sine theta over sine theta. So that this is going to be 1 minus sine squared theta over sine theta. That's equal to cotangent of theta cosine theta. I did not move anything on the right side. So one of the things that you got to learn to see is the Pythagorean identity. So this one's going to be cosine squared of theta. Is that okay? And then I can split this. You know, if you watch the Naruto, like kind of like Shadow Clone, right? So this he can split the two. So there'll be a cosine of cosine theta over sine theta. What is cosine over sine? So therefore you got the right side equal to the left side. Yes. Yeah, don't work out right side. Just stay on one side first. So usually you work one side at a time. You do not work both sides at the same time, and you do not subtract both sides or you do not multiply both sides. You just strictly work on one side. You're proving one side is equal to the other side. That's how you establish your best proof. cotangent square. I'm going to use x rather than t. And the cosecant of x is equal to cosecant of x minus sine of x. So let me make sure I write down the question right. Cotangent square of x, cosecant of x, cosecant of x minus sine of x. That's a good question to start off. Did anybody try this question? Yes? What you did?
Me?
Mm-hmm.
The cotangent is cosine over sine, and then cosine square over sine square.
Cosine square of x over sine square of x times 1 over cosecant of x, like this?
Yeah.
Okay.
No, I did like the cosine over sine over 1 over sine.
Over 1 over sine? Okay, that's fine.
Yeah, and then I did like the cube change.
So you're saying this?
Yeah.
Okay, fine. And they keep change flip, so be cosine square of x, sine square of x times sine of x over 1, right? Okay, what else?
Multiply it so you get rid of the sine.
Okay, so you can cancel out one sine, and then cancel out one sine, so this is going to be sine. So it'd be cosine square of x over sine of x. And then, what else?
I did omega loss. Yeah, and then I did the same thing. I did like I converted the other side and then made it 4
Okay, so don't convert the other side. This side you can do further than this. What is cosine equal to? Yeah, 1 minus sine square. Does that make sense?
Huh?
So can I split that? Because bottom's 1 term? And that becomes cosecant of x minus sine of x. Like, can I change this cosine square to 1 minus sine square? And then that's equal to this. So this is equal to this. I didn't move left side and right side. I just strictly moving on the left side. I strictly do things on the left side. And I'm just trying to focus on finish that part off. Any other questions? What happened?
Denise said thank you.
Oh. It's almost feel like she's here. What? I didn't say there was a test. Did I say there was a test? What?
In the group chat, you texted the kids there's gonna be a test. I'll check the group chat.
Okay, so any questions? So let's go through some harder one. Okay, so verify identity. It has a couple things. So first thing I want you to understand that usually you want to convert to sine or cosine. So usually you convert the sine to cosine, right? And they usually will result to something. Second thing you want to think about is you want to think about maybe identities. For example, sine square of x plus cosine square of x is equal to 1. For example, like this. Or the variation of this, sine square of x equal to 1 minus cosine square of x, or cosine square of x equal to 1 minus sine square of x. Those are the things that you might deal with. Even double angle identity. Cosine of 2x can be cosine square of x minus sine square of x. You can use that. Or you can use 1 minus 2 sine square of x, or equal to 2 cosine square of x minus 1. So you can have a lot of identity you can work with. Third, algebra, factoring. So can you deal with factoring? Can you deal with difference of a square? Where's Alex? Man, there's a lot of missing kids today.
Yeah.
Ending. Okay, difference of the square, factoring, all those are part of the, also splitting. Do you guys remember what splitting? So a plus b over c equal to a over c plus b over c. Another technique that you can think about is combined fractions, which is we did a couple of them, combined fractions. The last technique I want to talk about is conjugate. So pretty much all this 5 technique should be enough for you to verify something. I do want to mention some of the identities that a lot of people don't forget. Is this sine of negative x equal to negative sine of x, because they are even function, they are function, and the cosine of negative x equal to cosine of x. And the tangent of negative x equal to negative tan of x. Because this is odd, this is even, and this is odd. Sometimes you're going to have this that deal with any kind of verified identity. So sometimes you're going to have those issues. But normally you're not going to have too much of this issue. So we're going to start with this one question. Cosine of x over 1 plus sine of x plus 1 plus sine of x over cosine of x. And that's equal to 2 secant of x. Yes.
Why is cosine times negative x equals to like positive cosine?
Okay,
Why
it's
not negative?
very good question. So first of all, read it correctly. It's not times. So make sure that it's not times, is the argument. It's like square root of x plus 1. X plus 1 is the argument. So in this case, the argument is negative x. So it's not cosine times negative x. So if you have thinking that it's cosine times negative, it's actually cosine of negative x. So read it correctly in the future. That's going to help you with different situation. If you see parenthesis, always of rather than times. So cosine of negative x. So what I mean, remember even function, you look at this function. When we talk about cosine function, so cosine of x, look at this. It has even to y symmetry, just like your face. If you have even function, they have symmetry from left to right. So in this case, this is symmetry left and right. So this is an even function. That means if I plug in negative x, so if I say cosine of negative x, so if I type in the cosine of negative x like this, I'm going to get the exact same thing. Because it doesn't matter if I plug in negative x, both sides going to be matching. But sine, however, is different. So let's say sine of x is like right here. But if you type in sine of negative x, what will happen? it's gonna have asymmetry. It's kind of like a double hedron, so like in the biochemistry. Um, so actually, surprisingly, is MIT was able to find a way to levitate a water droplet. Have you seen those experiments before? So you can MIT was able to um, have a speaker on the top and a speaker on the bottom and produce the same exact frequency from the top and bottom. And basically just change this to like vertically, like this. Okay? So basically this is horizontal, but it's vertically. And this part is called a node. This part is a node. And they can insert the water droplet on the nodes because the both sound kind of cancel out each other over there and kind of push against each other. So the water droplet can suspend in on top of the nodes between where they cross each other. So I'll show you. Since we talk about this, I thought sometimes it's always interesting to see different things, like what is the application. So levitate water drops. Let me see if I can find it. MIT. Do you see that? Winston? So the top part has a some type of wave, sound wave, and the bottom part is sound wave. They kind of like cancel each other out. So when they cancel each other, where the note is, where insert the water droplets, it's gonna suspend right in the middle. Okay, so people always think about math is not useful. It's really useful. It's just something that you don't usually see. Like things like this is where the math go into the science. Okay, so a lot of things, and I will say like I personally I usually like to see the correlations between the math and science. But it's very important. Hopefully you guys kind of interested about what it can do. But you can actually buy a kit that does that now online that does that. So we are proving from the left side equal to the right side. Okay. So you guys want to try first? Oh, you did it? You did it? Nice. Okay, so Winston did it. Good job. Which side's more complex? Obviously the left side, right? So well, we have two fractions, so what can we do, right? And so I want you guys to try it. I think Winston did it, and so I want you guys to try to see if you can accomplish this job. This is just a lot of algebra. It's more like algebra manipulations, but you got to learn how to the work through the details. Okay, so Sophia, this is a good question for you to go through. Is working through details and make sure you organize your thinking, and this is a part that is gonna separate yourself between um, um, between my student versus other people's students. Is I'm gonna train you go through those details. So let's try this question, see if we come up with it. I think one person come up with it. We'll give you a few minutes for you to work on it. So we talk about combined fraction, factoring, identity. It's pretty much have everything up here. And don't miss the argument, Saphir. X is always there. It's like you guys have to understand those are very, very crucial things. Like, math start with like simple. It gets more complex. It gets a lot more complex than this. This is just actually compared to what you're gonna do next year. This is not hard. See how many people can get it. Gabby and Larissa is also in the band. Where's Larissa? She's in the band too. Why do they do a band on the block day? So stupid. I need to have my own field trip. Math field trip all day. You gotta learn math all day. Yeah, look for simplification. Always look for simplification. Look for identities. Look for factoring. Look for difference to the square. Look for Pythagorean identities. You got it? Nice. So two people got it. See if we can get a third one. Keep a track of everything. here. Apple. Ksenia. Olivia. Maybe Winston can help you a little bit. So what I'm gonna do is I'm just gonna leave the right side alone. I'm not gonna do anything. I'm just gonna do the left side.
Yeah. Int is 1 minus 9. So then
I will do that. Those are the
this is away, this gets away, this gets away.
Amelia, you got it? No?
Right?
how's the one go away?
1 minus 1.
Well, I put plus one.
Oh, yeah. That's 2. Right. That's 2 plus 2.
Yeah.
Int is actually
Put it all in there, so it's
like the same thing with 2.
All right. We're gonna start off on the top. I need a common denominator. What's common denominator between 1 plus sine of x and cosine of x?
1 plus
Yes, so what do I need on the right side? What do I need on the left side? Cosine of x over cosine of x, right? What do I need on the right side? 1 plus sine of x over 1 plus sine of x. Okay, so far, everybody understand? Okay, so this one's gonna be cosine of x times 1 plus sine of x. The top part is going to be cosine square of x plus, now I'm going to expand this. 1 plus sine of x times 1 plus sine of x is going to be 1 plus 2 sine square, 2 sine of x, right? Plus sine square of x. Now, I always tell people, it says, brown bear, what do you see?
You get that from? Yeah, that.
I'll write down the side. 1 plus sine of x times 1 plus sine of x. This times this is equal to 1. This times this is equal to sine of x. This times this is equal to sine of x. This times this is equal to sine square of x. And that's how you got 1 plus 2 sine of x plus sine square of x. Now, this is the part that you guys need to see. Cosine square plus sine square is equal to what? 1. So it'll be 1 plus 1 plus 2 sine of x over cosine of x times 1 plus sine of x. Can I change that to 2 plus 2 sine of x over cosine of x times 1 plus sine of x? Can you do that? What else can I do here on the top? Factor out 2. So 1 plus sine of x, cosine of x of 1 plus sine of x. What do you see? Cancel. 2 over cosine of x, 2 secant of x. Done.
Like that. That was fun. Do it again. Do it again.
You do it. Have you seen a book? We grew up, Brown Bear? Brown Bear, what do you see? I see a blue horse looking at me. Blue horse, what do you see? I see a yellow duck looking at me. I had to read it for my kids, so I know. Yeah, all you gotta do is so it's all algebra. It's all algebra manipulation. It's not something that's very, very scary. So I'll give you one that's similar so you can work through it. It's not much change. So this one is very similar. It's almost identical actually, but
Yeah, I don't even two questions of the exact same change.
but we need to build from that because it's not like it's hard to give you something that's completely out of blue. But we gotta build from that sometimes. Unfortunately, that just that's just a learning process. You're learning to build small things and then learn how to build big things. But mostly algebra. So I'm trying to train you algebra skill to be on top of things. We are gonna get to a more complex one in a second. So we're gonna start with easy and then yes.
What's the denominator of the first term?
1 plus cosine of x. The second one is 1 plus cosine of x over sine of x. Then it's already done. This one I'm not gonna go over, but I'm gonna let you guys go over with each other if you're missing it. But I'm gonna give you the next challenge. This one's kind of hard. What? It's sine of x over 1 plus cosine of x, 1 minus cosine of x over sine of x. Now this one require one of the skill I just write for you. So you gotta think about which skill that's gonna be involved because you're gonna find out that this question is gonna give you a loop situations where you feel like you're not going anywhere. But it's actually easier than you think. Everybody in this room need to get through the first question. If you need help, ask your friend to help you. Everybody got a first one or no? Anybody did not get a first one? Raise your hand. Elias, did you get first one? Okay.
Yeah.
Amelia, you helping her?
What did you get? What do you mean? What did you get? The last one? Yes. And plus, usually divide, multiply, yeah. That's it. Multiply here. Sine squared.
It equals y minus cosine.
This is 1.
Yeah, that one's kind of tricky.
Wait, which one?
That one has one of the special technique I had mentioned beginning. Look at your notes. I give you like all the technique. There's one technique you need to do. Huh?
Wait, what's the what's the problem? I basically prefer this. No.
One
Wait, what is it?
All right. Shanti, you got it? You got it? All right, let's talk about second question rather than first one. Second question is a little bit more tricky because second question, I have mentioned all those skills. Which one I didn't use? What's the only thing I did not use? What's the only skill I did not use for all the previous questions? Huh? We have used split on the homework. Conjugate. The problem is you can split this, right? If you split this, that's just going to be cosecant of x minus cotan of x, and that get you nowhere. And that just kind of like in a bad situations. So what we can do is we can worry about one side. Let's pick a side. I'm going to pick the left side. I'm going to multiply this by conjugate. Why do you think about conjugate? Because conjugate can make a difference of a square happen. Difference of a square can make other identity happen. So what we're going to do is we're going to multiply by 1 minus cosine of x. Do you remember conjugate we talked about very beginning of the year? With the i's, right? So we multiply the left side with the conjugate of the bottom. Anna, come back to me. He was zoning out. Okay, so here it's going to be, if I multiply this and this, what am I going to get? What's the difference of square? This is a minus b, right? A plus b. What's a times b times a minus b? Equal to what? A squared minus b squared. Good. So what would it be? 1 minus cosine square of x, right? Is that okay? Okay. Brown bear, what do you see? That's a sine square, right? Now, can I cancel one of them? And does that equal to 1 minus cosine of x over sine of x? And this is a conjugate. This is where you have loop situation. If you keep on doing the wrong thing, it just keep on looking back to left side does not equal to left right side. But yeah, so this is a situation that you had to deal with conjugate. But because you cannot combine fraction and you cannot split. Split doesn't give you anything. So the last resort is think about conjugate. Lastly, complex fractions. You can be a fraction on top of fraction. Yesterday, people already do that. Let's see if you guys can figure out the way to do this one. So it'll be 10 of x minus sine, or actually plus sine of x O over 1 plus cosine of x is equal to 10 of x. So let's see if you guys can figure this one out. 10 of x plus sine of x over 1 plus cosine of x equal to 10 of x. This one you want to combine fractions or complex fraction. You finished? Whoa, that's fast. Winston, finish?
Um,
You got it? Sophia, you got it? Ksenia? Not yet. Lendon? Who's even that person? Who's song? All right, so let's try it. Well, obviously, the left side is more complex. Obviously, that I can convert this to sine of x over cosine of x plus sine of x over 1 plus cosine of x. So the problem is the top. The top is two things. Can I combine them? So I multiply this side by what? Cosine of x over cosine of x, right? And if I do that, I'm going to have cosine of x over sine of x plus sine of x cosine of x. Now, I'm going to take this divided by this. Divide means what? Times 1 over 1 plus cosine of x. Does that make sense? Is that confusing? Because I have this fraction divided by this one. If you divide, that means keep, change, flip. Actually, am I going too fast? Do you understand or no? No? Okay, so let me write down maybe a little bit. Does that mean this fraction divided by this fraction? Right? Because it's one line, it's top divided by bottom, right? So can I write down division of 1 plus cosine of x? If it's a division, can I write down as sine of x plus sine of x, cosine of x over cosine of x? Is division, can you change to 1 plus cosine of x? Does that make sense? You got it? Now, what can I simplify here? Is there anything I can simplify? You can factor. If you realize that in here, those two things are identical. So we can have something called GCF factoring. And because if you factor out, that would have sine of x and 1 plus cosine of x over cosine of x times 1 over 1 plus cosine of x. Now, if you factor out this multiplying, I can just simplify. And that's equal to 10 of x, which is, that's what the question was. Some people say this is difficult. It's not. It's just, you just have to put some mind into it. And I got 10 of x. Confusing or no? Emma, do you understand? Sophia, did you understand?
Yeah.
You got it right? Are you sure?
Factor this one.
Yeah. Apple, did you get it right? But do you know where? Okay. The thing is, like, just, you know, see how can you fix each time, and I don't know, like, what's right, wrong. Okay, second thing I want to talk about today. That's why I think one of people miss this class, but a lot of Ben kids miss this class. They have to watch the whole video. Let's talk about two different type of coordinate. It's not bad. So you have to understand there is two type of coordinate. One is called Cartesian. That means the one that you know, x and y. Cartesian coordinate is also known as a rectangular coordinate. rectangular coordinate, so that means the same thing. Cartesian, rectangular, they all means the same thing. X and Y. Well, not yet. That's the calc 3. We're not get there yet. We gotta get to the pre-calc first. So the next coordinate I want to show you, it has a not X and Y. Rather than X and Y, it's gonna be R and data. Of course, you can go R and data. And you're like, what do you mean by R? Well, what do you think R stand for? Usually R stand for radius. You can think that way. There's a name for it. Okay, so you can think about this as radius. And this is going to be the direction angle. So technically, I can have, for example, 3 comma pi over 4. What does that mean? Well, instead of rectangular, my coordinate is going to be a circular. And I'll show you this on Desmos. So this is how you're going to click it. Try it on the Desmos too. Everybody should try it because you guys are going to have to deal with polar graph. R, yeah, R, it will say R and angle. So they will give you a number and an angle. Now you guys should turn on the computer and try this. Get your computer out, get your cell phone out, it's okay. So I'm gonna click on the wrench. Do you see the wrench on the right? And do you see that there's a polar axis like this? Okay, I'm gonna click on here, and this is rectangular. And if I change this, it becomes a gridded polar grid. Well, sort of, yes. It's a unit circle, except there's more than one unit. It's 10 units, but
It's like, go out.
I made it like. And it's so like.
It's just so trippy.
yeah,
So you can pull this up.
yes. Yes.
Desmos?
Huh?
Desmos?
Yes.
What?
Okay, now remember that coordinate I was talking about. 3 comma pi over 4. Where do you think they look like? What do you think they locate at? 3 comma pi over 4. Where do you think? Which quadrant do you think is at? First quadrant. Okay. So what we're gonna do is we're gonna go to the first quadrant and go to pi over 4. So this is pi over 4. Does that make sense? And it's gonna be 3, so that's gonna be 1, 2, 3, 4. So this coordinate here, this point here, is called 3 comma pi over 4. That means it's going to the third radius, the concentric circle, the third circle, and then plug in at that direction angle. And then I will get, so this coordinate here is also known as, in the polar coordinate, it's going to be 3 comma pi over 4. So instead of x and y going x how many unit, y how many unit, is you go into like which circle you're going to go to and which angle you're going to go to. Does that make sense? So it's like, oh, this is like first time you've seen this, but it's, yes, abnormal, but it's not difficult for you to do. 1, you're just going to count. This is the first circle. This is second circle. And this is the third circle. You're going to go to the third circle and along with x-axis, along with that line. That line is called pole. And that's going to be 3 and pi over 4. Is that complex? Okay, I want you to use this thing, think about it. Now, here's the thing. R can be negative here. So, I'm going to show you what happened. Okay, let's ask you to draw this. What do you think about 2 and 5 pi over 6? So do you know where is that at? Like 2 and 5 pi over 6. Two and 5 pi over 6. Do you know where's that? Samuel, you're gonna go point it out. Where's 2 and 5 pi over 6 on the front of the board?
Go up there.
Yeah, go up there and point it out. Where's 2 comma 5 pi over 6? Everything is right. Everything is right.
-2?
No, positive 2. 5 pi over 6. 2 and 5 pi over 6. Huh?
What's x-axis? Never negative.
It's never negative because they go by the radius. That's the radius. That's not negative. Huh? Where? 2 and 5 pi over 6.
Again,
Gotta go 5 pi over 6.
well, it's 5. You did 5 pi over 6. Yeah.
Okay.
So then go to
That
2.
be
Yeah.
It's a positive 2. It's not negative 2.
Look. It doesn't get
But the x-axis is never negative.
so you're
Oh,
right.
you go
Negative?
both sides.
Okay, so this is very confusing, right? This is a 5, right? You see that this is 5? You see this is 5 here. Hold on. This is 5, and this is also 5. Not just the radius. It's not negative. Now, you can have a negative. I'm going to explain to you in a second. But this will be the second ring of the 5 pi over 6. So where's the second ring? Second ring is right here. Okay, second ring of 5 pi over 6 is right here. Do you see? This is a first ring, second ring. So this is 2, right? So, and then 5 pi over 6. So 2 and 5 pi over 6. Is this okay? Everybody understand? Okay. Now, here it gets kind of tricky. You can have infinite amount of representation of one coordinates. Infinite amount. Because you can always add 2 pi, right? You can say 2 and 17 pi over 6 is going to talk about the same coordinate. But you can also do this, though. Okay. So this one I'm going to show you first. So I'm going to cross this out. We're going to say, hey, -4 and the 3 pi over 4. Wait, you said -4. Now, what you're going to do is, you know how you go x first and then y? For me, I like to go to angle first. Angle is going to be, which angle? Angle is going to be 3 pi over 4. So 3 pi over 4 is roughly right here, right? And then I'm going to go to opposite. So if it's a -4, it's actually going to the 4th quadrant. Because 3 pi over 4 is positive, it's in this quadrant. If it's negative, it's going to be the opposite quadrant. Does that make sense? So it's going to be -4 here. So it'll be 1, 2, 3, 4. So this coordinate is actually -4 and 3 pi over 4. Why? Because you start looking angle first. Always look at angle first. You're going to go to 3 pi over 4. And then since they say negative, so you're going to go opposite of that angle. And then you're going to track it back. It becomes the 4th quadrant rather than 2nd. Yes.
It could still only be on like the 3rd and 4th quadrant.
No, negative just means the opposite of the direction. So you look at the direction first. So you're gonna go 3 pi over 4, right? And you're gonna go opposite of that direction because it's negative. Because you have negative r. So it's opposite of 3 pi over 4. So it's actually 7 pi over 4 rather than, and it's positive. Yeah, it'll be like that part as being negative. So just go into that angle first and go in opposite ring instead of forward ring, like going forward. Yes.
What if the 3 power 4 is negative?
3 pi over 4 is negative, that's just the angle. So today if I have today I have says 3 pi over 4, 3 pi over 4 is gonna be right. Negative 3 pi over 4 is right here, right? So negative 3 pi over 4 is gonna go here. And that's gonna be positive 5. So at this case, it's gonna be 5 comma negative 3 pi over 4. So you can have like that because that's just negative angle. That means going clockwise, going to go negative 3 pi over 4 and then go into the fifth ring. Now the opposite ring is because you have negative. Does that make sense? Okay, so now we have a polar coordinate. We also have rectangular coordinates, right? So there's a polar and rectangular. How do you convert one thing to the other? So there was a relationship that you already know. So I'm going to draw it out first. That way you can see why that is. So some type of, this is a point in some type of R data. But with the R data, you also have, this length is called a pole. But there's also this length here is the X. And also this length is Y. And also there is a theta. Okay, so there's always a triangle here. So there's always a theta. So this is something that you guys already know. First thing, we already know this. X equal to R cosine theta. You're like, what? Pay attention. If I solve for cosine theta, what am I going to get? X over R. That's adjacent over hypotenuse. Does that make sense? And there's Y equal to R sine theta. Opposite over hypotenuse. Nothing that we don't know. Everything we already know. We did not do anything else. We do this is just a completely normal situation that we already know. We also know something else. X squared plus Y squared equals R squared. Pythagorean identity. We also know the last thing. Sine, cosine, we also know tangent, right? Y over X. So I'm going to draw this box. This to convert from polar to rectangular. This one is another box here. It's convert rectangular to polar. So we can convert from one coordinate to the other coordinate using some basic algebra. So let's try it.
What was polar?
Polar, what do you mean?
Convert from polar to
Yeah, polar is R and theta. So it's this is R and theta. Rectangular is X and Y, right? Does that make sense? And rectangular is x and y, and convert to polar. Polar is gonna be, I don't know, r and theta. Is that okay? So you can convert from one coordinate to the other coordinate. Okay, let's try to convert one. 2, comma 3 pi over 2. Is this polar or rectangular? Polar. Okay. If you're quick, you already know this x and y coordinate already, but if you don't, it's fine. Okay. So remember, we are convert from polar to rectangular, so we're gonna use the first two equations. X is equal to what? What is r here? 2 cosine of 3 pi over 2, right? Y is equal to 2 sine of 3 pi over 2. 0. What is sine of 3 pi over 2? -1, so it'll be -2. So 0 comma -2. So if I ever want to change this to rectangular, that's going to be 0 comma -2. This is the rectangular format, and this is the polar format. So you can convert from one thing to the other. Am I going too fast? Okay, so you guys gonna convert one. Now this coordinate might have some radicals, so you have to know. So it's a -8 and pi over 3. So I want you to convert to rectangular.
Yeah, yes, eventually.
Hmm?
It's like the CI dash without the I. So with the rule applied to this.
Hmm?
With the power rule applied to this too.
I don't know what you're talking about, Paolo. You find a rectangular coordinate? X equal to -8 times cosine of pi over 3. -8 times, what's cosine of pi over 3? Half. That's equal to -4. Y equal to -8 sine of pi over 3 is equal to what? -8 times square root 3 over 2. So that's equal to -4 root 3. So it'll be -4 root 3. Is that okay? Now here's my next question. I have a rectangular polar coordinate right now. I have a rectangular Now, how do I convert back to polar? So which equation I'm going to use a second time? Okay, x squared plus y squared is equal to r squared. That's the first thing. And then tangent theta is equal to y over x. So this is the first thing and second thing. So let's figure out what r is. Now, r can be positive, like I say, there's an infinite amount of representation of this. You have to figure out what's the correct one. There's infinite amount of representation of same coordinate. It's not like 2 comma 3. There's only one representation of that. You can have infinite amount of representation. So I'm trying to say is this. This is x. I can square this plus the y, negative 4 square root 3 squared equal to r squared, right? So that's equal to 16 plus 16 times 3 equal to r squared. R squared is equal to 64. R is equal to plus minus 8. Now, why is plus minus 8? Because sometimes you can have r is negative 8 represents same exact data. But we decide that later. Let's decide an angle. Tangent of theta is y over x. So what is y in this case? Negative 4 root 3 over what? Negative 4. So tangent theta is equal to square root 3. Positive. When is the theta? When's the tangent of theta equal to root 3? What is it? 5 over 3. Or where? Besides 5 over 3, there's other questions, or there's other situation that you can have. 4 pi over 3. So you can either choose a mix. Okay, sure. So for me, like, I understand the first quadrant. Like, for example, tangent of pi over 4 is always what? 1, right? Tangent of pi over 6 is always root 3 over 3. Tangent of pi over 3 is equal to root 3. That's how I know it's a pi over 3, not pi over 6. So remember the question started with a negative 8 pi over 3. So we're going to go with pi over 3. But we know that this is the fourth quadrant. Sorry, we know that this is the third quadrant. So it has to be negative 8. So you have to use some logic sense here. So we know this is a fourth quadrant. This is a fourth quadrant. So we say, okay, well, let's pick pi over 3. Let's pick pi over 3. So that's my data. But if I pi over 3, it's going to give me first quadrant. In order to get fourth quadrant, it has to be negative 8. And that's why I decided negative 8 pi over 3. Can I choose? Can I choose this for pi over 3 and 8? Do they represent the same thing? Because I'm going to go for pi over 3 and go to 8th ring. Or I can go to pi over 3 to opposite ring. So are they the same? Because I can go to pi over 3, right? Pi over 3 on the polar, pi over 3, which is right here, pi over 3, right? Think about pi over 3 over there, right? Yeah, I can go with the opposite ring as well. And this is how you convert from one thing to the other. Yes?
Polar force, if the angle is given us by like angle, like not pi force, just the angle. The negative still positive.
Negative, you can have negative angle. Like I said, you can have infinite amount of representation of the same coordinates. You can add 2 pi anytime too. If you add 2 pi, just go through the whole circle. I can have pi over 6 or 7 pi over 6 at negative 8. the same thing as negative 8 pi over 6. So look at it. I can have negative 8 and 7 pi over 3. They are equate to each other. Does that make sense? Because I can add 2 pi. 2 pi just go into a whole circle. A wheel is a wheel. It doesn't matter how many times you rotate. So this is same representation as this. And same representation as this. They are the same exact coordinate. All three coordinates are exactly the same.
Wait, what's a seven?
Huh?
7 pi over 3?
Yeah, 7 pi over 3. Because if you add 6 pi over 3, it's 7 pi over 3.
Oh.
6 pi over 3 is 2 pi. So you just add 2 pi. So if you add 2 pi, it don't change, right? So the way the trick is, if you want to add pi, then you change the ring to negative. If you add 2 pi, then you stay as a positive. Does that make sense? I'm going to say that again. If you want to get the same coordinate, I can add 2 pi, the r stays same as positive. Or I can add pi, which is 180-degree rotation, and change the r to negative ring. Then you're going to give you the same representation coordinate as everything else. So right now, I'm going to ask you to convert one. So I'm going to ask you to convert this as this. Negative 3 to 3. I want you to convert this to two different type of polar coordinates. Two different type. Give me two different type. One's positive r, one's negative r. You guys will have a mock exam at the March 29th, Saturday. That's a prom day? That's not a prom day. I suppose I have ping pong tournament, but I'm gonna sacrifice my ping pong tournament, so you're gonna sacrifice your time. Now, if you cannot make it, I know Liliana has regatta on Saturdays.
No, that's just the AP people not. Yeah.
A lot of you? For Phillips or for Farm? Okay, so you're gonna have to split up different times that you can come to make up the different dates. You are required to take one. There's total of 3, but you're required to take one. But I will take all 3. But you don't have to come on Saturday. We can do some in class periods. But one is I want you to take a whole test, straight shot, see how it is. See how much you really do know a little bit or not knowing too much. It's okay. Because the AP exam is a transition. You have to understand my test and transition to the actual AP exam is a little bit transition. The way we ask questions a little bit different. You have to learn see for that adaptation. So we have whole month to adopt what the AP College Board is going to be like. For us, the last year, if you are interested, last year was teach by Kench, me, and Ollie. Pretty much everybody is roughly the same part. I cover a lot of foundation. I teach a lot of very basic things. I didn't teach toward AP exam. So we didn't do any AP exam, but they've been doing AP exam practice since like couple months ago. My class result is still better than theirs. So roughly it's 89% for my class, 83% for Ollie, and 79% for Kench. So, but I don't teach toward AP exam. I teach the foundations correctly, so that way your next year you're not gonna struggle. But if you teach toward AP exam, then your following year struggle. So I don't want you struggle next year. I more emphasize on preparation for you guys for next year. You're not gonna have a hard proving identity like this on AP exam. They should, but they don't. So I'm gonna give it to you so that way you guys can see what is the rigor, what it's gonna be like in calc, rather than just enough for pre-calc. Pre-calc is gonna be, you just have to understand some basic things, some very good algebra, some very good trigonometry. You should be fine. You should get through with 3 or 4. In order to get a 5, it is a little bit harder, but I think most of you guys, especially group leader here, should have very good potential to get a 5. Most of the group leader got a 5 last year. And that's a part, I think Ollie does slightly better than me. He had like a few percentage higher 5 than I do, probably 2%. But that's because he's really focused on just prep hits for AP exam. I'm gonna do that this year too, but it's toward April. So we have enough time to prepare. Hopefully we get more 5 this year than last year. But I more care about if you get a 5 in calc. People get a 5 in calc in my class are 50%. 50% have 5s. So that's a part I focus on. I don't really focus on pre-calc because the pre-calc I don't think is a very easy test. But calc we have the highest. I think calc we have the highest in the state for us pass rate and the percentage who has 5. But that's calc. Pre-calc is everybody's new last year. So Kench, me, Ollie, we all new. I'm more experienced than they are, so that's why I'm a few percentage higher. It's not because of anything else. They are also very good qualified quality teachers. But I just don't think like I would teach toward a test. I hate the idea teach toward a specific test. I think that's stupid. But did you guys convert this?
What's 10 and negative? Like 10 doesn't equal and then 10.
It does. Well, I only write down first quadrant, but you don't have to limit yourself in first quadrant. Think about which quadrant is this coordinate in rectangular. I don't think so. I mean, you can get 7 pi over 4. You can also get 3 pi over 4. 5 pi over 4 is positive. Yeah, 5 pi over 4 and pi over 4 cannot. So let's start with this. So it'll be 3 squared. Actually, negative 3 squared plus 3 squared, right? So that's equal to 18 equal to r squared. So r is equal to square root 18, which is 9 root 2. What 2? Sorry. Is 3 root 2. Is that right? So it's a plus minus, right? So then we can pick out tangent theta is equal to 3 over negative 3, which tangent theta is equal to negative 1. When's tangent theta equal to negative 1? 3 pi over 4 and 7 pi over 4. Now, what I'm going to do is I'm going to pick, because I can have 2 choices of this, but only one right combinations, right? So if you want to really have right combination that you can actually just draw it out. Negative 3 and 3 is right here. It's in the second quadrant. So I'm going to choose the positive angle. So I'm going to choose the 3 pi over 4. Is that okay? So that's going to be 3 pi over 4. And the r, I'm going to choose 3 root 2. That's positive as well.
When you do 7 pi over 4 and negative 3 pi over 4.
Yes, you can pick 7 pi over 4 and negative 3 root 2 because they're the same thing. You're going to go to that and opposite ring. And you're going to get exact same situations. That's why you can say you can add a pi and change your r to negative. Add pi, change r to negative. So I'm going to write down this. Add pi, change r to negative. That's another way to do it. Because if you add pi, it's going crossing side. The crossing side, you're going to have a negative r. Does that make sense? Okay, yes.
I don't get why tan when it tan equals to negative 1, why is it 3 pi 4 7 pi over?
Because tangent is, see, this is y over x, right?
Yeah.
And y over x is, the only way you're going to get negative is the second and the fourth.
Oh.
Because that's the only way you're going to get negative.
Okay. Yeah.
Since you have negative 1, it has to be either second or the fourth quadrant, not first and third. First and third, you're going to get either both positive or both negative. So it will never be right. So I know like today is too much brain. I'm going to let you take a break. 20 minutes.
There's so much today, man.
So much? Is it?
I had 2 lessons today.
Do these rules apply for this too? So I can like square that and then just do the square.
You literally came into the apartment and you were glowing. I was like, this girl that's good. Yeah, this for the debate.